On June 30th, 1908, a fireball streaked across the Siberian sky and detonated with a force that would reshape scientific understanding forever. The explosion released energy equivalent to 15 million tons of TNT, more than 1,000 times the power of the atomic bomb dropped on Hiroshima, yet it left behind no crater, no debris, and no clear explanation. At 7:17 in the morning, near the Podkamenaya Tunguska River, witnesses reported seeing a column of brilliant blue light nearly as bright as the sun itself. A local farmer, 40 miles from the blast site, was thrown from his porch by the shockwave. The heat was so intense, he felt his shirt almost catch fire. Then came the sound, a series of thunderous bangs that echoed across hundreds of miles. The devastation was incomprehensible. In an instant, 80 million trees were flattened across an area of 800 square miles, laid out in a radial pattern pointing away from the epicenter like matchsticks. Seismic stations across Europe and Asia registered the tremors. The atmospheric shockwave circled the globe twice, detected by barometers as far away as Britain. For nights afterward, the skies over Europe and Western Russia glowed with an eerie luminescence. People in London could read newspapers outside at midnight without artificial light. The night sky pulsed with strange silvery clouds. Something unprecedented had occurred, yet the world barely noticed. This was remote Siberia, barely mapped and sparsely populated. It would be 19 years before the first scientific expedition reached the site. In 1927, Soviet scientist Leonid Kulik led a team into the remote wilderness, expecting to find a massive impact crater and potentially valuable meteorite fragments. What he found instead deepened the mystery. There was no crater. Zero. The trees at ground zero were still standing, stripped bare of branches like telephone poles, while millions of trees around them lay flat on the ground. This pattern told scientists something crucial. The explosion had occurred in the air, somewhere between 5 and 10 kilometers above the Earth's surface. An airburst. But what could explode with such devastating force and leave virtually no physical evidence? Kulik spent years searching for meteorite fragments and found almost nothing conclusive. The composition of the object, whatever it was, seemed to have vaporized completely. The theories multiplied over the decades. A stony asteroid that disintegrated in the atmosphere. A comet made of ice that evaporated entirely. A chunk of antimatter annihilating itself on contact with normal matter. Some even suggested a mini black hole passing through the Earth, or a UFO crash. In the 1980s, scientists found microscopic silicate and magnetite spheres in the soil, consistent with a cosmic impact, but the debate raged on. Modern computer simulations support the asteroid airburst theory. A rocky object roughly 60 meters across, entering the atmosphere at over 50,000 kilometers per hour, would experience tremendous air pressure and heat. At a critical altitude, it would explode catastrophically, releasing its kinetic energy in a massive blast wave without ever touching the ground. This explanation fits most of the evidence, but here's what keeps scientists awake at night. The Tunguska object, whatever it was, exploded over one of the most remote regions on Earth. 800 square miles of uninhabited forest. If the same object had arrived just 4 hours and 47 minutes later, the Earth's rotation would have placed St. Petersburg directly in its path. Millions of lives would have been lost. Today, scientists estimate that Tunguska-scale events occur roughly once every 300 years. The last one was over a century ago. We've mapped less than half of the near-Earth objects large enough to cause a similar catastrophe. Somewhere out there, another cosmic projectile might already be on an intercept course with our planet. The Tunguska event reminds us that we live on a shooting gallery in space, protected only by probability and vast emptiness. So here's the question that haunts astronomers. When the next Tunguska comes, will we see it in time? And more importantly, will it hit another empty forest? Or will we be standing where St. Petersburg was on that June morning in 1908?